is Ashley Nicole Aluria from Grade 10 Diamond, and we will discuss about probability. Probability is the measure of how likely an event is to occur. It is expressed as a number between 0 and 1, where 0 represents an impossible event and 1 represents a certain event. Let's then talk about simple events and compound events. Simple events are events that have only one outcome. For example, flipping a coin and getting heads. This event has only two possible outcomes, heads or tails. Another example is rolling a 6-sided die and getting a 3. This event has 6 possible outcomes, 1, 2, 3, 4, and 5, and 6. While compound events are events that involve more than one outcome. For example, rolling 2 dice and getting a sum of 7. This involves multiple outcomes, as there are multiple ways to obtain a sum of 7, such as getting a 1 and a 6, or getting a 2 and a 5. Compound event, another example, drawing 2 cards from a deck and getting 2 hearts. This event has multiple outcomes, depending on the cards drawn, but all outcomes involve getting 2 cards that are hearts. Let's now move to mutually exclusive events and mutually inclusive events. What are the difference of the two? Mutually exclusive events are events that cannot occur at the same time. For example, drawing a card from a deck and getting a spade or getting a heart. It is not possible to draw a card that is both a spade and heart at the same time. Another example, rolling a die and getting an even number or getting an odd number. A number cannot be both even and odd simultaneously. Mutually inclusive event, it is events that can occur at the same time. For example, rolling a die and getting a prime number or getting an odd number. Some numbers satisfy both conditions, such as 3, which is both a prime number and an odd number. Another example, drawing a card from a deck and getting a red card or getting a heart. Some cards are both red and hearts, so they satisfy both conditions. And lastly, the mutually independent events and mutually dependent events. What are the difference of those two? Mutually independent events are events where the occurrence of one event does not affect the other. It does not affect the probability of the other event occurring. While the mutually dependent event are events where the occurrence of one event affects the probability of the other event occurring. For example of independent event, flipping a coin and rolling a die. The outcome of the coin flip does not have any influence on the outcome of the die roll, as they are independent events. Another example is tossing 2 coins and rolling a die. The outcomes of the coin tosses does not affect the outcome of the die roll, making them independent events. Examples of mutually dependent events: drawing a card from a deck without replacement. The probability of drawing a certain card changes depending on whether or not another card has already been drawn. For example, if a heart is drawn on the first draw, the probability of another heart on the second draw decreases. So it affects the probability of another. Another example, tossing a biased coin and rolling a biased die. The probability of the coin landing on heads or tails may affect the probability of certain outcomes when rolling the die. For example, if the coin is biased to land on heads, it may increase the likelihood of getting certain numbers on the die roll. We are now solving mutually exclusive and not mutually exclusive events. Number 1. Janet is going to an animal shelter to choose a new pet. The shelter has 8 dogs, 7 cats, and 5 rabbits available for adoption. If she randomly picks an animal to adopt, what is the probability it will be a cat or a dog? So the first step, we have to calculate the total number of animals in the available. 8 plus 7 plus 5 equals 20. Next is calculate the number of favorable outcomes for adopting a cat or a dog. So, 8 dogs and 7 cats, 15. Calculate the probability of adopting a cat or a dog by dividing the number of favorable outcomes by the total number of animals. The total number of animals is 20 and the favorable outcomes is 15. So 15 over 20 was 3/4 or 0.75. Number 2. In a bingo game, balls or tiles are numbered from 1 to 75. The numbers correspond to column on a bingo card. So sub B, column B, 1 to 15. Column I, 16 to 30. Column N, 31 to 45. Column G, 46 to 60. And column O, 61 to 75. If a number is selected at random, what is the probability that it is multiple of 5 or in the N column? First step, determine the number of multiples from 5 between 1 and 75. So there are 15 multiples, 5, 10, 15, and so on until 75. Next is determine the number of number in the N column, and there are 15 numbers in the N column, 31 to 45. Next, identify the numbers that are both multiple of 5 and in N column to avoid double counting. The numbers 35 and 40 are both multiple of 5 and in the N column. Lastly, use the formula for the probability of either of two events happening. Probability of A or B equals probability of A plus probability of B minus probability of A and B. To calculate the probability of selecting a number that is either multiple of 5 or in the N column. 1/5 plus 1/5 equals 2/75 plus 2/5 minus 2/75 equals 30/75 minus 2/75 equals 28/75. Where did those came from? We calculated the total number of balls or tiles in the bingo game. That is 75. Then, we calculated the probability of selecting a multiple of 5 by dividing the number of 15 over 75 equals 1/5. Then we calculated the probability of selecting a number in the N column by dividing the 15 over 75 equals 1/5. And since the event selecting a multiple of 5 and selecting number in the N column are not mutually exclusive, calculate the probability of selecting a number that is both a multiple of 5 in the N column. 2 over 75. Then 1/5 plus 1/5 minus 2/75 equals 2/5 minus 2/75 equals 30/75 minus 2/75 equals 28 over 75. So we are now on the independent and dependent events. Number 1, 2 number cubes, one red and one blue, are rolled. What is the probability that the outcome of the red number cube is even and the outcome of a blue number cube is 5? First, we have to determine the total number of outcomes when rolling 2 cubes. And there are 36 total outcomes when rolling 2 number cubes. 6 outcomes for the red and 6 outcomes for the blue. Determine the number of outcomes where the red cube shows an even number. And there are 18 outcomes where the red cube shows an even number. 3, 4, or 6 on the red cube. 6 outcomes for the blue cube. Then, we need to determine the number of outcomes where the blue cube shows a 5. There is 1 outcome where the blue cube shows a 5. Then calculate the probability that the outcome of the red cube is even and the outcome of the blue cube is 5 by dividing the number of favorable outcomes by the total number of probability. So the probability is 18 over 36 or 0.5. Number 2. An aquarium contains 5 male goldfish and 6 female goldfish. You randomly select a fish from the tank. Do not replace it. And then randomly select a second fish. What is the probability that both fish are male? So we have to first determine the total number of fish in the aquarium. And there are total of 11 fish, 5 male and 6 female. Next, determine the number of outcomes where the first fish selected is male. There are 5 outcomes where the first fish selected is male. And determine the number of outcomes where the second fish selected is male, given that the first fish selected was not replaced. There are 4 outcomes where the second fish selected is male. 4 male fish remaining after the first fish is selected. Next, calculate the probability that both fish are male by dividing the number of favorable outcomes by the total number of outcomes. The probability is 5 over 11 times 4 over 10 for approximately 0.182. Sheila rolls a pair of number cubes. What is the probability that both numbers are odd if their sum is 6? First, we have to determine the possible outcomes when rolling a pair of number cubes. The possible outcomes are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Next, identify the outcomes where the sum of the number is 6. The outcomes where the sum of the number is 6 are 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. Then, identify the outcomes where both numbers are odd. The outcomes where both numbers are odd are 1, 5, 5, 1, and 3, 3. Lastly, calculate the probability of rolling a pair of number cubes where both numbers are odd and their sum is 6. The probability is 3 over 36 equals 1/12. Number 2. The probability that it is Friday and that a student is absent is 0.03. Since there are 5 school days in a week, the probability that it is Friday is 0.2. What is the probability that a student is absent given that today is a Friday? It's Friday. First, determine the total number of outcomes when a student is absent or present. And there are 5 total outcomes, the school days when a student is absent or present. Next, determine the number of outcomes where it is Friday and a student is absent. There is 1 outcome where it is Friday and a student is absent. Next, determine the number of outcomes where it is Friday and there is 1 outcome where it is Friday. Then calculate the probability that it is Friday and a student is absent by dividing the number of favorable outcome by the total of outcomes. The probability that it is Friday and a student is absent is 1/5 or 0.2. Then next, calculate the probability that a student is absent given that today is Friday by dividing the probability that it is Friday and the student is absent by the probability that it is Friday. The probability that the student is absent given that today is Friday is 0.2 or 1.